Hi, everybody. Alex Miller here at Capneon. I'm with my colleague, Jack Phillips. You may have seen our videos over the past few weeks demonstrating access control. There's encrypted data on a web page. We have this plugin that'll decrypt it if you have permission. And then you can dictate who that plugin does give that permission to actually see that data. This is not really our main trick, though. The analytics crowd out there will agree that a lot of the work you might do on data is not really about seeing the data itself, it's about relationships in it. So we're going to show you an example where you pull down that spreadsheet and you analyze how similar the names are. You might be doing data quality stuff. You might be just generally deduping a list of names. And you can do this work without actually seeing the underlying data, just getting the high-level insights you need via the relationships in the encrypted data. And Jack's going to show you an example. Take it away, Jack.
Absolutely. So this page here just shows an encrypted spreadsheet. I've shown you this page before with our plugin. Previously, we had permission to decrypt some, but not all of the rows here. Now we don't have permission to decrypt any of the rows. So I'm just going to go down here to the bottom and download this encrypted spreadsheet, which I've conveniently already uploaded to a Jupyter notebook. And over here, we have the Jupyter notebook, which we're going to try and perform some of these analytics that Alex talked about. So now I'm just going to run the whole notebook for everybody. And you'll see at the end here, we are able to import the data from the CSV we downloaded off the web page. And as you can see, all of that data is still encrypted. And when we come down here, we try and decrypt it, and it kicks back that we don't have access, which is exactly the behavior we want because we don't have access. But here we've defined a custom bigram distance function that does just as it says, takes the bigram distances, compares the strings in the first name column. Maybe you're looking for duplicates, maybe you're doing something else with your data, but you can define any function that you want here and it'll work for your purposes. So we're just gonna run these. And as you can see, despite the fact that we have no access to the underlying plain text, we can still do this meaningful string comparison and determine which names down here are the same, which names are different, and how different they are. This is a really neat trick to be able to do this on an encrypted data set that you don't have any access to the plain text.
Yeah, and just to emphasize a couple things here, that bigram distance function, that was written in much the same way you would write it if you were working with plain text data. So there's not a lot of new tricks for a user to learn here. And then just the big picture is you put this encrypted data set out on the web, and it was secure out on the web because it was encrypted. Later, you can decide to give people different permissions to see or learn different things about it, including learning these relational things like how similar names are without actually needing to see the names. And that's really the unique trick, or one of the unique tricks that's in Ghost PII.